Today's problem is minimum penalty for a shop. You are given a customer visit log of a shop, represented as a string called customers. This string contains only two characters, Y and N. If the character at a given hour is Y, it means customers visit the shop during that hour. If the character is N, it means no customers visit the shop during that hour. Now, the shop can choose to close at any hour J, where J ranges from 0 to the length of the string. The penalty is calculated in two ways. First, for every hour when the shop is open and no customers come, the penalty increases by 1. Second, for every hour when the shop is closed and customers do come, the penalty also increases by 1. Your task is to determine the earliest hour at which the shop should close so that the total penalty is minimized. One important detail to remember is that if the shop closes at hour J, it means the shop is closed starting from hour J. That's the full problem statement. Now let's move on to understanding how to approach this problem efficiently. Example 1. The input string is YYNY. Each character represents 1 hour of the shop's operation. Now, we try closing the shop at every possible hour and calculate the penalty. If we close at hour 0, the shop is closed all day. Customers come at hours 0, 1, and 3, so we get a penalty of 3. If we close at hour 1, the shop is open at hour 0 with customers, which is fine. But customers come at hours 1 and 3 when the shop is closed, giving a penalty of 2. If we close at hour 2, the shop is open for hours 0 and 1, both with customers. At hour 2, no customer comes while the shop is open, so no penalty there. At hour 3, customers come while the shop is closed, giving a penalty of 1. If we close at hour 3, the shop is open at hour 2 with no customers, adding a penalty. And customers come at hour 3 when the shop is closed, adding another penalty. Total penalty becomes 2. If we close at hour 4, the shop is open until hour 3. Only hour 2 has no customers while open, giving a penalty of 1. The minimum penalty is 1, which occurs at hours 2 and 4. Since we need the earliest hour, the answer is 2. Example 2. The input is NNNNN. No customers ever come. If the shop stays open, every hour adds unnecessary penalty. So the best choice is to close immediately at hour 0. This results in 0 penalty. The answer is 0. Example 3. The input is YY. Customers come every hour. Closing early would always cause penalties because customers would arrive when the shop is closed. The best strategy is to stay open the entire time and close at hour 4. That way, no penalties are incurred. The answer is 4. We are given a customer log where Y means customers arrive and N means no customers. Our goal is to decide when the shop should close so that the total penalty is minimum. There are only two ways to get penalized. If the shop is open but no customers come, we get a penalty. If the shop is closed and customers come, we also get a penalty. Let's start by assuming the shop closes at hour 0. That means the shop is closed all day. So every Y becomes a penalty. In Y, we have 3 YS, so the initial penalty is 3. In code, we initialize the penalty as the count of YS. We store this as our current minimum penalty, and assume hour 0 as the best closing time. Now we move forward 1 hour. At hour 0, a customer comes. Since the shop is open, we remove 1 penalty. Whenever we see a Y, and the shop is open, we reduce the penalty by 1. Since the new penalty is smaller than before, we update our best answer. Closing at hour 1 is now better. At the next hour, another customer arrives. Again, the shop is open, so the penalty drops to 1. This is now the lowest penalty so far, at hour 2. At hour 2, no customers come. The shop is open, so this adds a penalty. The total penalty increases again. Even though the penalty becomes 1 again later, we always choose the earliest hour with the minimum penalty. So hour 2 stays our answer. And now we'll see explanation and full code. Problem intuition. We want to decide at which hour the shop should close so that the total penalty is minimized. 2 types of penalties exist. Shop is open but no customers come, N, plus 1 penalty. Shop is closed but customers come, Y, +1 penalty. Our goal is to find the earliest hour where this total penalty is minimum. Key idea: optimization insight. Instead of recalculating the penalty for every possible closing hour, we start with the penalty if the shop closes immediately, hour 0. Then move the closing time forward hour by hour. Update the penalty incrementally in O(1) time. This makes the solution O(n) instead of O(n squared). Step 1. Initial penalty, closing at hour 0. Penalty equals customers.count, y. If the shop closes at hour 0, it is closed for all hours. So, every y customer arrives while closed contributes +1 penalty. Total penalty equals number of y in the string. Step 2. Track the best answer. Min penalty equals penalty. Closing hour equals 0. Minute penalty keeps the lowest penalty seen so far. Closing hour stores the earliest hour that gives this minimum penalty. Initially, closing at hour 0 is our baseline. Step 3. Move hour by hour for hour, visit and enumerate customers. We simulate keeping the shop open for one more hour each iteration. Step 4. Update penalty dynamically. Case 1. Customer comes, y. If visit equals y. Penalty minus equals 1. Y. Previously, this y caused a penalty, shop was closed. Now the shop is open, so the penalty is removed. Case 2. No customer, n, else. Penalty plus equals 1. Y. Shop is open but no customer arrives. This adds +1 penalty. Step 5. Update best answer if penalty. Minute penalty. Minute penalty equals penalty. Closing hour equals r +1. If the new penalty is lower, store this penalty. Store the closing hour, r +1 because closure happens after this hour. Step 6. Return result. Return closing hour. This guarantees minimum penalty, earliest possible closing time. Alright, logic is ready. Penalty is tracked dynamically. Earliest minimum is locked in. Let us hit run. Time to submit this solution. Single pass. No extra space. Exactly what the problem wants. And boom. Accepted. All test cases passed. Minimum penalty achieved perfectly. If this helped you, like the video. Subscribe for more clean LeetCode explanations. See you in the next problem.